Okay, guys, right. This is the last double page spread in the topic. This is the last chapter, 16.5, and then we're almost done, which is exciting. So anyway, this is all about. This is called cosmology. Cosmology is the study of the universe as a whole. Okay, but this part looks at, like it says, the beginning and the future of the universe. So how the universe started and how we reckon it might end up. So this is when it gets really, really quite interesting. So first lesson today, we'll look at the beginning of the universe, and I think in the second or third lesson we'll look at what's going to happen in the future. But today's all about the beginning. Where did the universe come from? Now, you would have heard of this before, because it's one of the most famous theories in the whole of science and the whole of mankind. It's called the Big Bang Theory. Now, this describes, quite simply, how the universe started and where it came from. So it's a description of how the universe started. Okay? Because, like I said in a previous video, it wasn't, we didn't always think this. Okay, it was Edwin Hubble 19 years ago that first observed the universe and concluded it to be expanding. But before then, everyone just assumed, everyone believed that the universe was static, that it was just stationary. It wasn't getting bigger, it wasn't getting smaller, and it had been like that for eternity. Okay, that was called the steady state theory. So it's quite a recent thing, this Big Bang theory. This is only 90 years ago, and it's like all new mind blowing out the box theories. It was not accepted at the time. In fact, there was a lot of controversy over it, especially amongst physicists. I mean, a lot of physicists just didn't believe it. They were like, they thought it was a crazy idea that the universe was basically started a long, long time ago as a very small object that's been expanding ever since. Okay, and in fact, the name Big Bang Theory was given to this theory as a joke. Okay, it was a derisory name because the physicists at the time who opposed Big Bang Theory kind of said something along the lines of, "Well, it's absolutely crazy to think that the universe started as a Big Bang." Okay, but the name stuck, and the theory has been known since as the Big Bang Theory. So, what's the evidence for it? A lot of people say, "Oh, it's just a theory. It's just an opinion." Not at all. Okay, it's quite useful to understand what the word theory means. A theory is is a description or explanation of something using good science that is based on evidence. That's the big part. It's something that's based on evidence, and there's lots and lots of evidence. This is not just a guess. This is not just an opinion. This is a theory based on evidence. So let's get started. What is the evidence for the Big Bang Theory? There's quite a lot of it, but I'll just cover the main three parts of evidence. Now, the first part we've already looked at. It's the fact that the universe is expanding. So, like I said, 90 years ago, Edwin Hubble observed that all galaxies are moving away from each other. Now, the only explanation for that is the whole universe is expanding. Well, if this is the universe today, then yesterday it was slightly smaller. And the day before that, it was slightly smaller still. Now, if we kind of stop the tape and rewind, the universe would be getting smaller, getting smaller, getting smaller. But logic dictates that if it's been expanding at a roughly constant rate throughout its lifetime, it must have originated from a tiny point, with a tiny singularity. It's called a singularity, where all the mass, all the matter and energy in the universe was concentrated into an infinitely dense point. Okay? So that's the first bit of evidence, the fact that the universe is expanding. It must have been smaller yesterday and smaller before that. So it must have come from a single point. Okay? Now, a lot of people think, well, the universe is what's it expanding into? It's incorrect to assume that the universe is like a balloon being inflated, and the balloon is expanding into empty space. Okay, all of space and time is contained within the universe. Outside is literally nothing, not even time, not even space. I know that's a difficult concept, but we'll have to live with it for now. Okay, so, but everything, all physical quantities, time and space, all the mass, all the energy is contained within the universe. Outside literally is nothing. Okay, right, anyway, first bit of evidence, the universe has been expanding ever since. It must have come from a singular point where everything was concentrated. Okay, now this timeline here is quite easy if we know the speed at which galaxies are moving away from each other, and we know the distance between them, we can use speed equals distance over time. It's as simple as that. Now, if we get a value of time, we know how long it's taken for these two galaxies to move away from each other, then that amount of time is when the universe started from. Okay, and scientists have measured this and come to got a value for the age of the universe to be, wait for it, about 14 billion years. Okay, so just by measuring the expansion of the universe, we're quite confident the universe is 14 billion years old. Anyway, what's the second piece of evidence? Second piece of evidence is this thing. This is actually a map of the universe, a computer-generated map of the universe, but it's a map of something called the cosmic microwave background radiation. Basically, it's like the afterglow of the Big Bang. Okay, you know when you have a go out camping and you have a campfire the night before, and you wake up in the morning and you poke around in the embers, and there's some glowing red embers, isn't there? It's the same as this. It's like the afterglow after the Big Bang. Okay, and it's not infrared. It's actually microwave radiation. We've got all these microwaves whizzing around in the universe, and this was discovered fairly recently. I think it was about the 1960s, early 70s. This was discovered and analysed, and concluded that this is the actual afterglow of the Big Bang. And it's obviously taken a long time to cool down. The universe is 14 billion years. This is the afterglow 14 billion years later of the Big Bang. Okay. Now you can actually see this Big Bang, the cosmic microwave background radiation, CMBR. You can actually see this yourself. Ask your parents about this, but old-fashioned terrestrial TVs, this is pre-digital. Okay, this was an analog TV. It had an aerial on it, and it would TV signals in the old days were transmitted using microwaves. The microwaves were received on the antenna. Okay, but if you go between channels, if you tune the TV in between channels, you'll see all these black and white dots and that hissing noise. That is actually part of the microwave background radiation. Okay, that's an old-fashioned TV set, literally tuning in to the afterglow of the Big Bang. Okay, fascinating. Anyway, part number 3, the relative abundance of hydrogen and helium in the universe. Okay, going back to the Big Bang right at the start. Okay, it wasn't all galaxies and stars. Okay, going right back. Okay, before even atoms had been created, subatomic particles had been created. Before even that, the universe was just energy. Okay, but then particles are created like neutrons, protons, electrons, then atoms are created. So the first atoms to be created were obviously the smallest ones. And the smallest ones are hydrogen and helium. Now, estimates in the universe is that this is by mass. Okay, by mass, 73% of the mass of matter in the universe is hydrogen. 25% is helium, which leaves how much? That leaves 2% by mass of all the other elements in the universe. Now that is very, very strong evidence that the universe was created in a Big Bang that involved at the very start the creation of particles and then the creation of atoms. Now that model fits very, very well with the Big Bang Theory. Okay, so there you have it. Just to summarize, there's your 3 bits of evidence which you need to learn about. Evidence for the Big Bang. The universe is definitely expanding. So if it's the same, if it's the size it is today, it was smaller yesterday and smaller the day before that. The cosmic microwave background radiation. Okay, if you don't believe me that exists, find an old TV set and tune it into the background noise. And finally, the relative abundance of hydrogen and helium in the universe fits perfectly with the models for the Big Bang Theory about how atoms were created. Right, there's a quick run through. I've got a couple more videos for you to watch from the YouTube. Have a great day. Bye-bye.